So we are live. It looks like this is already live. Let's see. Uh, it's 9 o'clock sharp. Um, okay, so I see three concurrent viewers. Four. That's good. Okay, so I hopefully you can see my screen as I have announced in Twitter yesterday. I want to basically repurpose a bit this session, and I want to at the same time um, kind of call it a day, so to say, with this project, right? With the Qiskit textbook. So um, and the reason being that I kind of feel like it's not really engaging me the way that I would expect and the way that it would allow me to actually give you a good um, live experience on these. And so, this is mainly because of the direction that I want to take in the next weeks and months with the channel. And the time that I have basically to spend on this. So this is kind of the one main thing. The other thing would be, I want to at least use that session today to give sort of take a look back at what we've done in the book. Maybe go through the things because a lot of the I've seen just now like that they've added the face kickback chapter in here, and so there's a bunch of things that we can take a look at really quickly, sort of in a summary way, kind of try to summarize what we've done, and then take a sort of a quick view on what we haven't covered in the book, and that's kind of the sections 5 and 6, and then the demo 7. But it's going to be a rather short video, so it's going to be really, unless you guys have questions and we have sort of a started discussion in the chat or something. It's going to be a relatively short video. I just don't want to linger too much on those topics. But basically, so I wanted to do these two things. And maybe the first thing that we should start right away with is taking a look at the textbook and how it has changed. And you can see already, I mean, the first page, the preface, is really already the preface, or I think it's pronounced preface. It has changed already a lot. Um, it's just new content, I'd say. And what I'll probably do is I'll probably go through each of the chapters quickly, each of the pages quickly, and then take a look at and see if this basically. Okay, so look at this. So they've actually added a bit of guidance in here in terms of the structure of the book. So we basically did all the way down to the algorithms, I'd say, the basic algorithms exactly. So, and then you've got still these two options, and there's still the hardware option that's at the end. I have the feeling, this may be my first piece of feedback here. I have the feeling that this book can become huge. As one of the maybe one of the things that kind of uh, makes me feel like not super engaged with it anymore is the fact that it's it's just it feels like it feels a bit rushed, and it's not because the content is rushed, but it's because it tries to cover a lot of topics at the same time in one single book, so to say. um, and it's a weird combination. I don't even know how to say this, but it's a weird combination of um, the first three chapters of the book. It kind of almost like doesn't feel like you need Qiskit, you know what I mean? Like you do have the introduction was really good. The rest of the stuff you're using Qiskit for is just building circuits. Um, and it maybe does not, I mean, which is kind of Qiskit's, it's what Qiskit is, right? It's just like the core of Qiskit would be to, help you build the circuits and interact with the real backends, I'd say. Um, and then I'm assuming that in chapters 4 and 5, you really start to get some of those built-in things that you have in Qiskit, right? Like VQE and QAOA and stuff like that. You have like in other parts of Qiskit. Um, but it's one of those things where it feels really stretched. It feels like it doesn't invite the reader to sort of um, kind of stay in for a while, deep dive into some topics. Now, maybe another way to put it would be, it kind of feels like it's more of a skeleton at the moment rather than like a fully fledged and fully well, um, developed and thought through book. It's getting there. I think, for example, so I just took a look. Let me just jump to the face kickback thing, for example, which is a new addition to the book since, I don't know, some time. Um, but basically, this is this is the kind of stuff that I personally love. So I haven't gone through all the details, but basically, you've got an entire chapters just focused on exploring the C note gate and face kickback from that perspective. Um, and so, and up until before that section existed, this was just barely like mentioned somewhere in another chapter. Um, but here you really, take the time to go deep into these and okay, analyze what the C note is doing, um, and basically taking a look at different. I mean, that's really, I think, really well done because it's really, at a deep sort of. It helps you really understand how the things work. Um, Maybe not deep inside in the hardware, but how the things work at a small scale, right? And so it's not like, hey, here you've got the algorithm, it works. Here's the mathematical proof. I'm done, right? So that's kind of the stuff that I don't like much. And here's a bit more like, here you have the state, and here you have this in here, and then what's happening here, right? In this case, is that when you do a control node, you're swapping the phases in here, right? So it actually will swap the amplitudes of 0, 1, and 1, 1. So this would swap implicitly the phases as well, right? So you've got the state vector in here, and so it really takes you step by step to just one element that then, you know, it's something that's applied in many algorithms. So that's a good example of sort of the direction um, that I would like to see the book going towards, or that I think it would be useful. Oh, and even for the T gate, I see. That's cool. And then I mean, probably there's some exercises about doing it with another gate or something like that. So that's yeah, that's a good example. I'd say that's a good example. Um, on the stuff so this hasn't, I think, probably changed a lot. Qiskit linear algebra, introduction to as I said, if you have any questions, feel free to ask. If not, I'm just going to go through these fairly quickly, and there's some error in here. Another thing that it's interesting is that it, despite the fact that like the whole USP of this thing and of IBM and the IBM quantum experience and whatnot is it's really the real backends, right? I mean, it's that's kind of what makes it different from everyone else in the industry right now is that IBM Q provides you access to actual real hardware. And while that's really cool, it just doesn't feel like I think it doesn't feel, it's something. It feels really redundant that in every section you're like, oh, that's the simulator, that's the real machine, that's a real machine, and it doesn't really feel like. I realized I haven't used it at all, and maybe when you go through the actual quantum hardware using microwave pulses part, right, which is the lowest level. It's the lowest level possible. This is the lowest level. And that's actually, I have to admit, pretty cool. Come on, we're again with internet connection problems or what? I'm not here. Calibrating curves and open pools. So I have skimmed through that in the past, not on a video, but literally the idea here is you can basically define the 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 the, the pulses that are sent to the qubits, right? So you can actually manipulate this one machine, and you can manipulate. There's one machine that's kind of available to be manipulated down at that level, which for educational purposes is really interesting because you kind of see how the whole thing is really, it gives you a bit of an extra insight on how the whole thing is kind of built in, is built up. But and for research, it's probably really useful because you can calibrate that. Also, something about accessing higher energy states and whatnot here. So it really kind of feels like you can fine tune the machine to your needs. Um, But like, I don't know, it still feels like for the newcomer and someone who's actually coming from a computer science background and doesn't really do any active research in these, it's not like doing something fancy with quantum simulation yet and whatnot. Um, this part in here maybe could be somewhere else, or maybe my point is I think it got to a point where it feels like it's, everything packed in there, like you try to pack everything that the IBM quantum experience offers, um, which I mean again might be fine for some people, but it just overwhelmed. I think it overwhelmed me a little bit. Um, but it's probably the only part I'd argue where the actual real machines make more sense. Uh, yeah. I mean, make sense at all, because otherwise you're just playing with a simulator. It doesn't make any sense, right? When you fine tune the pulses and whatnot. So, what else? Representing qubit states. No. So we were here at the introduction part, the items of computation. I'm not gonna go anywhere with this speed here. Splitting information into bits. I think this hasn't been. There's probably some minor updates here and there, right? That's of course for sure the case, but come on. Dun, 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 dun. This is really so representing qubit states. Oh, this is something new in here. Hmm. It feels. Click here to expand. Aha. So there is indeed. Okay, so this, but this is another thing. There's a lot of different there's a lot of playing around with different formats and different things, and it almost feels like each section has been done by someone else in a completely in a completely independent style, which is kind of good. But at some point, I think if you want to make it feel like a solid, consistent work, there's um, a bit of a look and feel that you probably want to standardize, I guess. But that's really not a major issue. So. Classical versus quantum bits. In quantum physics, we use state vectors to describe the state of our system. This is different from classical physics, where we generally just use numbers. For example, we say we want to describe the position of Carl on a track. This is a classical system, so we'll use the number x. Alternatively, we could instance a collection of numbers in a vector called state vector. Each element in the vector contains the probability of finding the car in a certain place. Okay, interesting. Qubit notation. This is also new. Remind matrix addition. So there's some reminders to previous sections. It's like it's funny because it's kind of also, the level that you're treating some of the concepts in here versus what you can probably find in VQE is there's sort of a huge gap, I'd say. So that's also another. Exploring qubits with Qiskit. Initialize. State vector simulator. Okay. So this is okay. Okay. So this is a bit more. I think that's also the rules of measurement. Okay. Cool. A very important rule. No, I think that's good. I think that's a good. Um, that's one of those other good additions, like the phase keyback. So it really takes you down. Oh, global phase. Oh, so you talk about the global phase. Okay. No, that's nice. The observer effect. Information about the probability of us finding the qubit in the, but once we have measured the qubit, we know with certainty that what state of the qubit is. For example, if we measure qubit in state. Mm. A note about quantum simulators. using a real quantum computer, we cannot see the states of our qubits mid-computation, as this would destroy them. The behavior is not ideal for learning, so Qiskit provides different quantum simulators. Yeah, the block sphere, visually representing a qubit. Okay. Yeah, no, I think it's good. I think it's good stuff. Yeah, I think that's definitely qubit states, single qubit states, single qubit states. Here's the gate. The what is the I gate? Is it the identity, or I guess so, because they're walking you through different Qiskit gates, measuring in different bases. So there's again this whole thing with measuring in different bases. Why there's a measurement and a Hadamard afterwards, though? Yeah, anyways, so there's some exercises in between. Rotation gates, IETS and the T gates. I don't remember whether this section was going that deep or was a bit more superficial before. Multiple qubits and entanglement. I think this has been quick exercises. They've done, I think some of these exercises are extra. They were not here before, which is good actually. I think exercises definitely helps. Exercises do help because it depends on the exercise, honestly. So if you're mixing exercises like, hey, prove these or prove that, and then kind of something that's a bit more practical, it's again, it's a question of the audience, right? Entangled states. Qiskit we took a look at proving universality. I think we didn't even do this last time. More circuit identities, and I think here we talked about the Toffoli gate and the Controna gate. Control rotations, the Toffoli gate. Yeah. So, yeah, okay. So the problems here, classical basis, yeah, those were. Oh, the Hello Qiskit game. There's something else in here. Beginning with beats. Puzzle 1. Normal computers are made of beats. The simplest thing you can do with a beat. Try and update, see what happens. Is this sort of inspired on the Hello Quantum game from yeah, this is probably inspired on this the Hello Quantum game from Dekodoku, this game here, which is sort of a puzzle based okay, you've got different puzzles, different exercises. Interesting. And then you jump into the algorithms part. That's where we spend most of the sessions recently, going through the different algorithms. So if that would again, it's getting really laggy. I can't even move my mouse. Come on. Live broadcasting is not my thing. I already see this. Quantum interpretation. that's the same thing. I think superdense coding, Deutsch Josa, or however it is pronounced. The problem, yeah, I don't know. I don't think much has changed in here. The QFT definitely changed. I remember that was a good. There's a good change. So I don't know. I don't honestly wanna steal more of your time. Um, but so I have the impression, again, like and you probably feel that, but it's one of those things where I don't really feel like, oh, that's cool. Yeah, that was cool animation. Um, it's even difficult for me to. I was thinking about it yesterday quite a lot. Like, how could I approach the feedback in general? It, I don't know. It just feels it feels good, but it doesn't feel good. It's a weird mixture. When I take a look at the guide, when I take a look back at what we did and what's kind of coming ahead, right? Simulating molecules using VQE. Um, some of the maths in here, variational forms, okay. Parameter optimization. Structure of convolutional forms. No, it feels, it kind of feels everything's just, kind of packed in there and it's really work in progress. But it's good. I mean, it's not that's not bad necessarily. Um, it's a working it's sort of an alive thing, kind of, you're kind of evolving the book as people go through it and give you feedback, and that's I think that's really good. The error correction part I did in another video. I did cover this in another video because I needed it for a review that I was doing on a paper, and I found it good as well. I found it really nice. Where you're basically uh, where you're basically walking the reader through a way you can correct some of the, or you can correct the measurement errors, right? By basically building a model of those and then applying the model to your simulation. Um, so that shows a bit more of what's kind of, what's more powerful about Qiskit, or what's kind of built in Qiskit that you might not find in other languages. Maybe, I don't know. Um, da, 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 da. And the quantum volume part I also did. Yeah, I don't know. I'll probably I think I'm probably gonna wrap it up. All honestly, um, if I'd have to if I'd have to summarize the book in kind of like a sentence or two, I'd say this feels like coming from there's a really good initiative, but it doesn't feel like it's everything really well glued together, or it doesn't really feel like, this is something that you go through and you're like, okay, I got sort of a good feeling of all the topics that we've got to cover and whatnot. But it's, again, I think that's normal. So it just doesn't give me that. It doesn't. It gives me sort of a weird feeling at the moment that I'm not able to express either in words that probably make sense to you anyway. So yeah. So I think I'm gonna end up here unless anyone is kind of, has any questions or anything right now in the chat. I think I will basically, what's this? Estimating pi using quantum phase estimation. Ah, yeah, okay. So that was what was released in Pi Day about estimating pi. Hmm. I don't know. Um, I'll definitely be doing some of those parts at some point, because of all the videos and other things that other projects that I'm working on, and that I'll probably need maybe to go through some of those concepts. But I think I prefer if this is kind of more driven by the need to understand a bit more, whatever challenge I'm trying to go through, than rather just the textbook uh, in itself. So that's the main reason that I'm really stopping the sessions. Um, that it feels like just doing it for doing it. It's not kind of ticking anymore with me. QA, QAI, combinatorial optimization problems using QAI. That's definitely something that I want to touch in again at some point, for example. Anyway, if there's no other questions, I see there's some people watching, but if there's no other questions in here, then I'm just gonna wrap it up. It's been fun, and I think the textbook has a lot of potential, and the content that's in there, it's really good, but it's still, as I said, it kind of feels like there's something off to it, that if I basically manage to put some of my thinking straight, then I'll definitely share this with you, um, in one form or another. So good. Having said that, I think it's time to go, and stay tuned for more in the channel. And I hope you enjoy the next, and the sessions are following up with Sam, um, and other people in the textbook reading sessions. Yeah, cool. Then have a good day and have fun.